Hello. Now, continuing with our factor theorem, one of the important things that this allows us to do is to solve cubic equations. So if we're asked to factorize a cubic, so there wouldn't be an equal sign there, or to solve a cubic, which means find the values of x that make this equal to 0. So this essentially would mean find the roots of this cubic equation. If we're asked to do either of those things, there's something a little unusual that we have to do in order to find our first root or our first factor, and that is to do trial and error. So what we are literally going to do is start plugging in values of x and see if we can find one that's a root. So a bit unusual. So we start off with x is equal to 0. And as usual, there's a kind of a method to this madness. We're going to start off with x is 0. We'll very quickly see whether that's going to work or not. Then we try x is 1, then x is minus 1, then x is 2, then x is minus 2. And in an exam, they're very unlikely to give you anything that takes longer to find than x is 3 or x is minus 3. They're very unlikely to give you anything that's more than x is 1 or minus 1, in point of fact. But let's put this into practice. So we're going to try values of x, try roots of x, effectively, root values for x, and see if any of them work. Now I can immediately see this isn't going to work, but just for completeness, I'm going to write it down. So we start off by trying the simplest situation, which would be that one of our roots would be x is equal to 0. And I can see that I'd end up with minus 3 is equal to 0. Now that isn't true, therefore that's not a root. X is 0 is not a root. Let's try x is equal to 1. I get 2 on 1 cubed, minus 3 on 1 squared, minus 8 on 1 minus 3 is equal to 2 minus 3 minus 8 minus 3 is equal to minus 12, which is definitely not equal to 0. So x is equal to 1 is not a root. Next one I try is x is equal to minus 1. Then x is equal to 2, then x is equal to minus 2, and so on until I find one that works. And they shouldn't make it too awful hard for you. So we sub in x is minus 1 and see if this is a root. If it's a root, it will make our cubic equal 0. So we sub in and we get minus 2 minus 3 plus 8 minus 3 is equal to minus 5 minus 3 is minus 8. So 8 minus 8 is 0. So that does work out. So x is equal to minus 1 is a root. Is a root of our cubic. Now, from our factor theorem and also from practice that we've done ourselves, we know that if x minus 1 is a root, I can rearrange that, get it equal to 0. So if I rearrange that, make it equal to 0. Sorry, x plus 1 is going to be equal to 0. If this is a root, this is a factor. So this must be a factor. Now, once we've gotten to that point, there are two ways that we can go from here. We could use long division, or we could use our factorizing method. And I'm going to show you both. So we're going to start off with long division, and we're going to have x plus 1 is a factor. We know this for a fact. So we're going to write down 2x cubed minus 3x squared minus 8x minus 3. If I divide this in, and I know I'm going to get 0, 0 down here because this is a factor, what is left up here is going to be the other factor. So that's how I am going to get the other factors or the other solutions of my cubic. So our steps are divide, multiply, subtract, bring down. We keep looping through these. So divide x, the highest power here, into the highest power here. I get 2x squared. Multiply 2x squared by x is 2x cubed. 2x squared by 1 is plus 2x squared. Subtract. Take these away. I get 0 and I get minus 5x squared. Bring down minus 8x. And then we've gone through the whole process, so we start again. X divides into minus 5x squared minus 5x times. Multiply minus 5x by x is minus 5x squared. Minus 5x by plus 1 is minus 5x. Subtract. If I'm subtracting a negative, I end up with a positive in both cases. And I end up with minus 3x. Bring down minus 3. The whole process starts over one more time. X divides into minus 3x minus 3 times. Multiply minus 3 by x is minus 3x. Minus 3 by a plus 1 is minus 3. And subtract. Subtracting a negative is the same as a positive, and no surprise, because we already know that this is a factor, I get 0, 0 for a remainder. If I didn't here, that might tip me off that I could have made a mistake, either up here or in the long division. Now I've got a quadratic factor, and I like quadratic factors. I know how to factorize them. I can't directly factorize my cubics because I had to go into this trial and error method, but I do know how to factorize a quadratic. So let's do that now. If I want to find the factors of this, I'm going to be looking for the factors of 2x squared minus 5x minus 3. So I've got this factor, but I don't have all of the factors. I could factorize this. So that's what I'm going to do now as part of factorizing or solving, depending on what they asked you, my cubic here. So factorizing this, I multiply these two together, and I get 2 by minus 3 gives me minus 6. Then I'm going to look for all of the numbers that multiply together or to give minus 6. Or I could have minus 1 by 6 or minus 2 by 3. Which one of these is going to add up to give me the number in front of the x? It's going to be plus 1, and minus 6 is going to add up to my minus 5. So I get 2x squared minus x, plus x I should say, plus 1x. We can put the 1 in there if we like. Minus 6x minus 3 is equal to, I'm going to factorize the first two and then factorize the second two. So we have 4 terms. Try and take a common factor from the first two, common factor from the second two. So the common factor from my first two is going to be x. I am left with 2x plus 1. Common factor from the second two is going to be minus 3, and I'm left with 2x plus 1. So I don't have to do anything clever about taking out negative common factors or anything. It worked out fairly nicely. I get 2x plus 1 on x minus 3. Now if I was asked just for the factors, then my job would be done. But if I was asked to solve this, I would set these equal to 0 and I would solve them. And I get my 2x plus 1 is equal to 0, or x minus 3 is equal to 0. Rearranging this, which we know how to do, we'd get minus a half. Or rearranging this, which we know how to do, we would get x is equal to 3. So if we are asked for the solutions, if we are asked to solve we'd get x is equal to minus a half, 3, and the one that we found by trial and error would be minus 1. Those would be the solutions. If we were asked for the factors, we would be looking at x plus 1 was our first factor that we found, 2x plus 1, and x minus 3. Again, if we multiplied out all those three brackets, we would get back to the original cubic that we were asked for. So if we were asked to factorize, we'd do this. If we were asked for the solutions or the roots, we'd do this. Now, final aside, we didn't have to use long division here. We could have also used our factorizing method. So when we got to this point here where we got a factor, we could have said x plus 1. Give myself some space. We could have said x plus 1 multiplied by something must give me 2x cubed minus 3x squared minus 8x minus 3. What do I know? I know that at the first term in the first bracket and the first term in the second bracket multiplies together to give my first term, my cubed term here. So x by what gives me 2x cubed? It would be 2x squared. That's the first term in the first bracket. The last two terms must multiply together in order to give the last term here. So 1 by what gives me minus 3 by minus 3. And there's some term I don't know in here that I'm going to call px. If I multiply this out and equate coefficients, I will get the value of p, which I already know is going to be minus 5 because I did the long division. This is an alternate method. So multiplying that out, multiplying the left-hand side out, I get 2x cubed plus px squared minus 3x plus 2x squared plus px minus 3. Immediately I'm happy. I see that my first term and my last term have indeed worked out correctly. Then I'm going to gather my x squared terms and my x terms. P plus 2x squared plus minus 3 plus px minus 3. My coefficients must be equal to each other. This must be equal to this. This must be equal to this. So I can write down two equations. As it happens, I only need one because I only have one missing variable. P plus 2 must be equal to minus 3. And minus 3 plus p must be equal to minus 8. Rearranging these equations, I would get p is equal to minus 5. Rearranging this one, I would also get p is equal to minus 5. So a nice check that my method was correct. I got p. I got the same value for p from both of these equations. We know from other types of situations where we'd have more unknowns, we'd need our two equations to find all of our missing letters. But in this case, we just have two equations in p, and we're happy that we get the same answer for both. That would tell me that my second factor would be, my quadratic factor would be my 2x squared minus 5x minus 3, and I would factorize it as I did here. So this is just an alternate method. This is equivalent to this. So that's how we can use the factor theorem to factorize or solve cubic expressions or cubic equations. And that's what we need for now.